acceleration of the center of mass. So the force applied on a system is equal to sigma m into AC, where sigma m is the total mass of the system and AC is the acceleration of the center of mass. Now let's get familiar with one more quantity, which is impulse. Impulse is defined as the product of force and the duration of its application. So suppose we have a force F external, and this force is being applied on a system. Suppose this is our system for a small duration delta t. So delta t is, this is the duration for which the force was applied. So we say that the application of this force on the system for a small duration delta t will impart some impulse to the system. So when F external is constant, we can define impulse as impulse is equal to F external into delta t, where delta t is the duration for which the force was applied. If F external varies with time, that is F external is some function of t, where t is time, then we can define impulse as integration of F external into dt. Now we have already seen that F external is nothing but rate of change of momentum of the system, that is dp system by dt. So when we replace F external with dp system by dt, we'll get impulse is equal to integration of dp system. Now let's discuss Newton's third law. Newton's third law states that force can exist in pair only. Another way of stating Newton's third law would be, for every force of action there is equal and opposite reaction. To understand this, let's take an example. Suppose there is a block A. This is our block A, and we are exerting a force F on this block through a rod. So this is the rod, and through this rod we are exerting a force F on the block. So if we take the block separately, we can see that there is a force F which is being acted on this block. Now according to Newton's third law, the block will also exert some force on this rod. So suppose this is the force which is being exerted by block on the rod. Let's denote it by F1. So now we can see that this is our action force, which is being exerted by the rod on the block, and this F1 is our reaction force, which is being exerted on the rod by the block. So according to Newton's third law, the vector F is equal to minus of vector F1. This means that the magnitude of both these forces, that is F and F1, they are equal, and their direction is opposite to each other. So that's why this negative sign. Action and reaction forces act simultaneously and they disappear simultaneously. To understand this, let's get back to our block and rod example. So we have seen that on the block A, a force F was being exerted by the rod, and the block A was exerting an equal and opposite force F1 on the rod, and F was equal to negative of F1. So the moment this rod stops exerting force F, the block A also stops exerting force F1 on the rod. So the pair of forces F and F1, they act simultaneously and they disappear simultaneously. Action and reaction force act on two different bodies and their line of application is same. So let's again get back to our block and rod example. So we have seen that on the block A, a force F was being exerted by the rod, and the block A was exerting a force F1 on the rod. So here the F is action force and the F1 is reaction force. So we can see here that the action force, that is F, it is being acted on the block, and the reaction force, that is F1, it is being acted on the rod. So the action force and reaction force, they are acting on two different bodies, and also the line of application is same, which means that suppose the rod is in contact with block A at some point, so this is the line of application of force F, which is being exerted by the rod on the block, and the line of application of force F1, which is the reaction force being exerted by the block on the rod, is this. So this is a straight line.